Good morning.
Good morning, Professor.
Okay, we've got some people on the line. All right. All right, folks, we'll get started. So I think we had just finished the double displacement reactions, and we're going to now look at predicting and balancing decomposition reactions. We'll also look at some single displacement reactions today. That'll pretty much round out the material for test 1. So going back to the syllabus here, just want to make sure everybody's on track with what they're doing. And I just want to remind you of some of the due dates that are coming up. So we've got the homework is going to be due next week. And one thing I didn't put here and I should put is there won't be a class on test day. Okay, there will be no class on test day, which is going to be Monday of next week. The homework is going to be due on the 7th, which is Sunday 11:15. So all of the homework that we're talking about here is going to be due on Sunday 11:59. Sorry, at that's next Sunday coming up. We're going to have a review session on Wednesday of this week. It's optional if you want to attend or not. But one thing I will say is that the test can be taken anytime up to next Monday. All right, you don't have to take it on Monday. You can take it any time up to that. And I strongly recommend doing so earlier rather than later. Does anybody have any questions? Does anybody have any questions about what's going on?
You mentioned something about taking a practice test for getting like extra credit on the test.
All right, let me take a look. Let me take a look at that. Okay, so let's see, we're looking in the module 1 to 6 test folder. That's where you'll find this information. Yes, there is an opportunity. That closes on February 7th at 11:59 p.m. as well.
Which is Sunday.
Yeah, that's right.
Oh, okay. All right, thank you.
You have to get 80% on the sample module 1 to 6 test. All right, in order to access that, but you have to access it before. You have to get 80% before Sunday, February 11th. So February 7th.
Oh, okay. Thank you.
In the past, I have maybe a third of the class take advantage of this. And all I can imagine is that there's people out there who just don't like getting free points. I don't know. I'm not sure what that is, but that's kind of what I've been gleaning here. I'm hoping that more people will take advantage of that. I mean, the thing is that it can make up for homework you don't do as well. Yeah, that's the other reason to do the test is to, you know, if you can't get to all the homework, then, you know, at least get the extra credit on the test. Remember, this is a test you'll have to take anyway. So I don't know, why not take it early, get the extra credit? That's what I reckon. Anybody have any questions? Okay. Decomposition reactions. We're actually going to deal with a few of these. The first ones we'll be looking at will be chlorates and perchlorates. And then we'll look at some hydrates. We'll also look at some carbonates and hydroxides. Those are actually not in the soft chalk. Those I have a separate document for a separate video for decomposition reactions. But the questions are pretty clear, and I'll show you the questions in the sample test and how they relate to what we're doing. All right, so let's first of all talk about the chlorates and perchlorates. Okay. Now, chlorates have the ClO3 as the anion. So these are going to be chlorate ions. And perchlorates have ClO4. Now, it doesn't really matter which one we're dealing with. They pretty much go the same route. So that's a perchlorate. The general formula for any of these is MClO3 will turn into MCl plus O2. Now I'll put that in quotes because it doesn't have to be M just one Cl. It could be MCl, or we'll say X plus O2. So there's going to be always a chloride formed plus oxygen gas, O2 gas. So I'll show you some examples of these, and I'll show you. Well, I'll do the more complicated ones. But let's say we had CuClO3. We know that it's going to be some compound of copper and chlorine, or copper and chloride, I should say. So Cl negative will be the charge on the chlorine. And we have to figure out what the charge on the copper is. Now, the copper is going to depend upon how many ClO3s there are. You'll notice it's a -1 charge. So if there's one ClO3, then it will mean that the Cu has a positive charge. So that would be CuCl plus O2. So that's the first step. We have to figure out what the salt is, the chloride salt is going to be. Now that's not the end of it. We do need to also balance this as well. And this one is a little bit of a challenge to balance because we've got 3 oxygens on one side and 2 on the other. In this instance, you want to try and make it so that we can have the same number. So what we need is probably 6, 3 times 2. So that means I need to put a 2 in front of the CuClO3, which means a 2 in front of the CuCl, and then a 3 in front of the O2. And that would complete that balancing. Does anybody have any questions? All right, I'll show you another example here. Let's make it CuClO3 too. So again, it's going to be Cu and Cl. Cu is going to be, Cl is going to be negative. We're still going to have O2 as a product here, but copper is going to be 2 plus in this instance because we've got two chlorate ions here. So I continue on with that. I go CuClO3 2, and I make that CuCl2. Let me give stuff a little bit of room here. CuCl2 plus O2. Now to balance this, I need to look at how many oxygens there are, and there's 3 times 2 is 6, and over here we've got 2, so I'll put a 3 in front of the O2, and then that will be balanced. Does anybody have any questions? So you need to be able to do this for any metal that has a charge from 1 through 6. I'll say it again. You need to be able to do this for any metal that has a charge of 1 through 6. I'll show you a perchlorate as well, although it's not really any different to what we're seeing here with the chlorates. In fact, these are a little bit easier because the balancing at the end always comes out a tad easier because it's an even number of oxygens that we have. So the same deal, MClO4 gives MClX plus O2. So I'll give you an example here. Let's make it, we'll do a MO here. MOClO4. We'll make that 6. Gives MCl plus O2. The Cl is negative. The M is going to be 6 plus. So the metal charge will, sorry, MO. The metal charge is always going to be however many of the chlorates or perchlorates that we have with it. Does anybody have any questions? Okay,
Is the product always going to be O2?
Yes, absolutely. Yes, Joseph. And a metal chloride as well, Joseph. And that metal chloride will be determined by the charge on the metal, which we can always get by the number of chlorates and perchlorates. So looking at that, you can see that the chlorines are balanced because we've got 6 of them. We've got the MOs, they're balanced. The O2s, we've got 24, which makes that 12 in front of the O2. All right, does anybody have any questions about doing any of these? Okay. So let's look at, these are hydrates. I'll do the hydrates here because they're part of the setup here. Now, hydrates always have the formula X dot something H2O. We'll put an X here in front of the H2O as well, where the X is some kind of salt. Now, it doesn't have to be sodium chloride. When I say salt, I mean some sort of binary type combination. And I've got AB here, if you will, of positive and negative. Now, the idea here is, let's say it is CuSO4.5H2O. That dot doesn't represent a multiplication sign or anything else. What it represents is the fact that in this setup, each copper sulfate is surrounded by 5 water molecules. We can heat this. This is something you're going to do in the lab next week, actually. You're going to take hydrates and you're going to actually heat them. And you'll be able to figure out the hydrates based on what the formula of the hydrate is, based on the percentage of water that we're getting in this process here. So that'll be in the lab next week. So you can see that what happens is this here is actually blue. And this is actually white. So this is called the anhydrous salt. The prefix an means none, or so without water. An means none or without, so without water. So this is white, and the copper sulfate with the 5 waters around it is blue. So they're different compounds, but you can always heat the hydrate in order to get the anhydrous salt and water, which comes off as a gas generally and just goes off into the atmosphere. It boils off, essentially. But you can see you get as many water molecules as you have here, so they're not very difficult to balance. Does anybody have any questions about hydrates? Okay. So in modules 1 to 6 here, we got in module 6, focusing on that. There's a little bit more information about hydrates. So we've got decomposition of carbonates, decomposition of hydroxides, and also decomposition of hydrates, but I've already looked at that. So these are videos that you can access that show you how to deal with problems involving carbonates and hydroxides, which actually aren't part of the soft chalk. They are part of the test, and I'll show you what the test questions look like. And generally, to a lot of people who haven't seen them before, those questions are confusing. So it's a good thing that you're here today, because often I do get questions about these from people who don't attend the lectures. But let's look at, well, let's first of all make sure we understand what a hydroxide and what a carbonate is. So OH minus is a hydroxide. So I'm talking about compounds that have a OH minus in them. And the carbonates are going to be CO3 2 minus. Now these have a very specific way of breaking up. So let's say we have, well, we'll go with XOH here. And that's going to give some formula XO, an oxide, plus water as a product. And yes, it's always water, but we get it as a product. And carbonates will always form some sort of oxide XO plus CO2 as a product. And it's always CO2. Any questions so far? So X can be anything from X plus to X6 plus. So how are we going to know what the charge on X is? Well, it's actually not that difficult, especially in the case of hydroxides, and you'll see why in a second. Let's try some examples here. We'll go with XOH3. And as I said, the formula is going to be X and O, and then H2O. But we need to figure out what this XO business is going to be. It's very similar to what we just dealt with. So O is always -2. The X in this case is going to be 3 plus. And we know this because if I drew a picture of it, this is just like the chlorates and the perchlorates. We'd need a 3 plus on the X to balance out the hydroxide. So there's going to be 3 negative of those. And then the X is going to have to be 3 positive. Does anybody have any questions about this so far? Now the X, the X can be anything. It's not necessarily, it's supposed to be any particular element. The main reason I've put X in there is because the charge can vary. All right, so let's look at the balancing of the rest of this. XOH3, this would be X2O3. Again, the aim here was to make it so that these would even out, which means that 2 times 3 is 6, which means 3 plus times 2 would be 6 plus, -2 times 3 would be 6 minus, and that's plus H2O. So then we would balance this, and we could do that by putting a 2 in front of the XOH3 to get the X2 going. And then we needed, let's see, we got 2 times 3 is 6 hydrogens and 2 oxygens. So, sorry, 3 oxygens, 6 oxygens. So it looks like, yes, we would need a 3 in front of the H2O. That would give us the 6 hydrogens, and then we'd have 3 plus 3 is 6 oxygens. So that would balance out. Does anybody have any questions? Okay, I'll do a carbonate here. So XCO3 2. And again, it's going to be X and O combination plus CO2 as a product. The O's, let's see, the XO compound, that's O is -2. And the X here is going to be +4. Now, the reason for that is because CO3 has a -2 charge. So if I drew a picture of that, that would be X4 plus. So that would mean that the -2s would be cancelled out with the +4. And I have, yeah, I'll just have to delete that. Okay. So just balancing this out now. So the XO compound is going to be XO2, because that's how many O's would be required to balance out the X charge and the CO2 there. So to make sure we get this balanced, let's see, we've got X is fine. O we need 6, but we'll handle that in a second. We've got 2 carbons. I'll put a 2 in front of the CO2 there. That would mean we'd have 6 oxygens, so it would be balanced. Does anybody have any questions? All right, I'll show you what these look like on the test in a little bit, but we'll do one more thing here. We'll do the single displacement reactions, then I'll come back and I'll show you what these decomposition questions look like on the test. The chlorates and perchlorates you won't find on the test, but you will find them in the homework. So that's why I went through them. But on the test, you'll have hydrates, hydroxides, and carbonates. But we've only got one more thing here to look at, so we'll do that, then we'll go to look at the test. So we're going to focus here, first of all, on the single displacement reactions. And you can see that these have a very specific pattern about them. They start off with a solid and then something aqueous, and then we end up getting the metals kind of swapping out. So the solid metal becomes something aqueous, and the aqueous metal becomes something solid. So this calcium here, which is solid, turns into calcium 2+, and the copper here, which was 2+, turns into copper 0. So anything with a solid happens to not have a charge on it. And we can always determine the charge of something aqueous by looking at the number of the anion that we have. So if we've got 2 nitrates, nitrate has a -1 charge. There's 2 of those. So that would mean copper would have to be 2+. So you can see that these are what's called redox reactions or oxidation reduction processes. Now, whether this reaction occurs or not is dependent on what we call the activity of the 2 metals that we're dealing with. And generally speaking, we can look at a list here of metals, which will tell us which metal is more active than another metal. But the other thing that's important is that if a reaction is occurring, we'll know because we could actually make an observation as to whether that reaction has occurred or not. And the kinds of things that we see when chemical reactions occur include bubbles and color changes, the precipitation of new solids, things dissolving, that kind of thing. So it's usually pretty obvious if something is reacting. And if there's no change in a situation, so if you put a metal into some sort of solution, you don't see anything happening, there's no change or no reaction, then we know there's no reaction occurring. So we can use that to figure out if something is happening or not happening by looking at whether a reaction occurred or not. This will then tell us whether something is more active than something else. So we actually don't need this list here in order to solve these kinds of problems, because in any problem we have, we'll always have the actual data as to whether or not the reaction occurred or not. But this is the main rule that we're going to be looking at here, and I'm going to go ahead and rewrite that here. So if element is more active than cation, reaction will occur. If the element is less active than the cation, reaction will not occur. So what do I mean by element and cation? Well, the element is always going to be the solid, and the cation is always going to be part of the aqueous solution. And that's pretty easy to tell, because the solid will always be some sort of single element, in this case calcium, and the cation is going to be part of the aqueous part here with the AQ after it. So it's always easy to tell. So let's look at some examples of these. So I don't think we have anything here. We'll look at, I'm going to close this down. I'll show you what this looks like on the test, and we'll go back and take a look at the decomposition. I think this is how it looks in the homework as well, just so you know. Where are we? Okay. Sample module 1 to 6 test. I think this is the last question. Maybe not, we'll see. It's one of the last questions anyway. Yeah. Okay, here we go. So here's an example of the kind of question that deals with single displacement reactions. me see if I can shrink this a little bit. There we go. Okay. So looking at this, you should easily be able to tell what I mean by element and what I mean by cation. So the element will always be what's in whatever's solid, and the cation will always be what's part of the aqueous solution. So the observation here is what's going to tell you whether a reaction occurred or not. This one says no changes. But if it said something like bubbles and solid changing color or solution changing color, then you'd know a reaction was occurring. In this case, there is no change, which means there's no reaction. So the answer to the first part here would be no for reaction. The neutral element, well, that will be the copper. The cation, that will be the potassium, or the K as K plus. And more active, well, look at the rules here. If the element is less active than the cation, then the reaction will not occur. So that's the thing. We know the reaction didn't occur, so we know that the element is less active than the cation. So the less active one is going to be the copper, because that's the element, and then the more active one is going to be the potassium. So you can see the way that these are set out. They're set out with the answers here. So what you'd be looking for would be no, Cu, K plus, more active would be K, less active would be Cu. So you would just find that answer within the groupings. Does anybody have any questions about this one, about number 31?
Why do we make C, what did you say? K plus? Why do we do K plus as the cation, but just K for more active?
Because when we're talking about what's more or less active, it goes with what the element is. But the only reason we're able to tell that is by looking at what the compounds are as neutral elements or as cations. But you know, when we're talking about that list just has the elements in it. So it's when we talk about more active and less active, it's the elements that are more active and less active. Is that clear?
Yes, thank you.
Okay. Any other questions about number 31? All right, while we're here, well, actually, no, I'll re-roll this. I'll show you another example of this before we go on to the other ones. Oh, no, sorry, wrong thing here. That one's pretty similar to the last one we had. I'll show you an example here, and we'll put in the answers. Let's make it. We'll do. We'll do Mg plus Cu NO32. We'll do that one. And the observation here brown solid. Solution turns colorless. We'll say from blue to colorless. So what we can definitely say from that, as far as reaction goes, reaction, yes. Neutral element, that would be the Mg. Cation, that would be Cu2 plus. More active and less active. The more active one would be the magnesium, because a reaction occurred, and the less active one will be copper. So if the element is more active than the cation, then a reaction will occur. So we're actually using that data to make that determination. Does anybody have any questions? So everybody's fine with that, hey? All right. Let's look at some of the other questions here that related to the decomposition reactions, and that would be these here, 32 through 34. These are the questions I get most questions about, but generally just from people who didn't attend the lectures or hadn't, you know, the first time they see it is when they take the sample test. So hopefully you guys will be able to understand what's going on here. So look at what is being asked for here in question 32. What is the sum of coefficients from the following reaction? So we need the, and yeah, the most common question I get from people who haven't seen this before, obviously, is, well, what's this X? How do we deal with this X? So the product is always CO2, and that's always goes with the carbonates here. O is going to be -2. The X here is going to be 4 plus. This is similar to the one I did earlier. So XCO32 plus heat will give XO2 plus CO2. Then to balance this, I'll need to put a 2 in front of the CO2, and that will balance everything. And the sum of coefficients then would be 4. 1 plus 1 plus 2 is 4. Does anybody have any questions? What is the formula of the metal oxide formed from this reaction? This one, oh, it's the same one. Well, I've already got that. It's going to be XO2 solid. Oh, well, yeah, well, XO2 solid, but it doesn't really matter what the state is here. So that would be your answer, would be XO2. That's what you'd put down. Anybody have any questions? It's the same thing as we got up here, coincidentally. What is the formula of the metal oxide formed from this reaction? This is XOH2 plus heat. Well, we know that X and O, so X is going to be 2 plus, O is going to be 2 negative. We're going to get water as a product here as well. In this case, we're just interested in the formula of the metal oxide, which is just going to be XO, because 2 plus and 2 minus are going to cancel, so it'll just be XO. Does anybody have any questions?
I do. For
Yeah.
back for the XCO3 in parentheses 2, wouldn't that make it actually, wouldn't that make one of the products X2 because each CO3 has a -2 charge?
Well, that means the X is 4 plus. I'm not really following here.
Yeah, that's what I meant. It would have a +4 charge, not a -2 charge. Oh wait, that's an O2. Never mind. Never mind. I
You're right?
saw it.
Okay.
Yeah,
Alright.
I saw the 2.
All right.
How did you get the X4 plus?
From the if you draw a picture of this, CO3 has a -2 charge. Now you can get this off the polyatomic ion sheet.
Yeah.
So -2 plus -2 is -4, which means X has to be +4 to balance it out.
Oh, okay, I see. Okay, thank you.
That's always how you'll get the X. Now, in the case of the OH, it's a little bit different. OH is -1 charge. So that's going to be X2 plus to balance that out.
Okay, yeah, because 4 minus 2 is 2. All right, I see. Thank you.
Well, it's more because -2 times 2 is -4, and that means +4 needs to balance it out, code.
Okay.
All right. Does anybody have any other questions about the decompositions? Any other questions? All right. Let's go back here. I want to let me see if I can. I don't think I can get out of this any other way. I'm going to have to submit it. There's also a quiz here for the homework. And it's this one here, the Module 6 decomposition of carbonates, hydroxides, and hydrates quiz. Now, you can't access this unless you do the assignment, and then you can access, and then the, yeah, I think it's just the assignment you have to do in order to access this. It could be the practice quiz too. All right, let's have a look. Okay, so these are kind of similar to the ones we just looked at, but this is on the quiz that you'll do as part of the homework. So these are sort of practice for this as well. So it also tells, when I get questions about this on the sample test, it tells me that people haven't accessed this via the homework, so they haven't gotten to this in the homework. So let's have a look at this one, X2CO3, and we're looking for the products here. So it's going to be X and an O plus CO2. The X here is going to be 1 plus and the O is going to be -2. Now, how did I get the 1 plus? Well, that's because if I drew a picture of it, it's going to be X, X, and CO3 -2, which means these have to be each 1 positive in order to make that work out. So to balance this now, it's going to be X2CO3 plus heat gives X2O plus CO2. Now to balance this, well, it's already balanced here. So that one's balanced. Does anybody have any questions? What is the sum of coefficients from the following reactions? So XOH plus heat now gives X and O again, plus in this case water. In this case, X is 1 plus, O is -2. So XOH plus heat gives X2O plus H2O. To balance this, we need to put a 2 in front of the XOH, and that will balance everything. The O's, the H's, so that one's fine. Does anybody have any questions about this one? What is the sum of coefficients from this reaction where X dot H2O plus heat? Well, this is a hydrate, and that's going to separate into simply X plus, in this case, just one H2O, because there's only one H2O there. Does anybody have any questions? Okay. What is the formula of the metal oxide formed in this reaction? So X2CO3. Again, we're going to get XO plus, XO plus CO2. So the O is -2, the X is 1 plus. The formula would be X2O for the oxide. But that will be the answer there. Any questions? And last one. Well, we've already done this one. So XOH plus heat. The formula for the oxide there would be X2O. That would be the answer. Now, obviously, this is going to change depending on what X is, but X can be anything from 1 plus through 6 plus. The videos I've put in here for decomposition go through every single example from where we have something that's 1 plus through something that's 6 plus. So you can see all of those in the videos that are in the Module 6 folder. Does anybody have any questions at all about this? Any questions at all? Okay, let's talk a little bit about what you should be doing as far as homework goes, and again, how you would know what homework you've done, what homework you haven't done. What I would do, and I'm going to go in here and view as a student, is pretty regularly I'd look at my grades section. And if you look at test 1 here, you've got all the homework and how many points that each of those things is worth. And you can get a very good idea, well, of what you've done, because it's very unlikely you ever get 0 on a quiz, especially with 2 attempts, but I suppose it's possible. But you should be able to see how many points you're getting from each here. And if you've got a 0 next to it, I think the chances are good you haven't done it. And you need to take steps in order to figure out how to do it. And you can see the decomposition of carbonates and hydroxides and hydrates is here as well. And here's the sample module 1 to 6 test extra credit. That's a bonus that goes in there. I think it's worth 5 points. So it is worth doing, I think, especially if you've missed homework, because it can make up for some of the homework you might have missed. Then you'll take the test, and the test will be done under honor lock, and then you'll be able to see your grade and everything by looking in your grade section. Does anybody have any questions? We've got a fair number of people here today, so that's good. But I know there are some people who are absent, and those people I think will be sending me mass emails pretty close to the due date. That's usually what happens. But I'd really like to see as many of you do that extra credit as you possibly can. I don't know why people don't do it. It's beyond me. Anybody have any questions? Anybody have any questions? No questions, huh? Really? All right. So the test is accessible via the Module 1 to 6 test folder. I don't know if I pointed out the study guide to you. I'll go ahead and do that now just in case. So these are all the question types that are possible for each question. I mean, for some of these, there is just one type of question possible, so it's easy to predict. But for other ones, like this 3 to 4 business here, this could be any of these. So these two questions could be any of these kinds of questions. The number 6 here could be electronegativities, ionization energy, or size. So any of those three. So the best, because there are certain questions for which there's more than one kind possible, the best thing you can possibly do to study for this test is simply to do the sample test over and over again. So each time it will bring you different kinds of questions to answer, but you'll know the general kinds of questions you're expecting by looking at the study guide. Now, when you open the test, and then I think we discussed this before, but it's worth saying again, you don't need to have any reference sheets printed because all the reference sheets are embedded within the test. And usually the reference sheets, generally speaking, not all the time, but generally speaking, they're pretty close to the areas where you're going to need them anyway. So you've got your periodic table, also a list of elements and compounds as well. And then you can see you've got your conversion charts here, conversion factors, and those are pretty close to where you need the conversions. But you've got your polyatomic ion sheet, again, another periodic table as well to help you out. Chemical reactions, again, the polyatomic ion sheet, the periodic table, and a solubility chart. And all those are in here, and you'll be able to get through all of that. Does anybody have any questions? Anybody got any questions about the general structure of the test or anything? Any questions? So the real test you take is a copy. It's just a copy of this test, right? It's just a copy. So we could go on.
Sorry, how many questions is the test?
Well, let's have a look. You can take a look at the down here. 34, Karina. How do I know that? Because it's the same as the sample test.
Okay.
You don't believe me, do you? You think that the other test is going to be completely different, don't you?
I don't know. It's kind of too good to be true.
Well, people still fail it, even though, I don't know, people still fail it. Even though it's the same test, people still fail it. You know why they fail it? It's because they don't do the sample test at all.
It is the same test. I already took it.
Oh, see, it's, Abram, thank you so much. So you see, I didn't even plant that, Karina. Abram volunteered that information.
Yeah, the president, you're 10 steps ahead, knew that question would be asked, planted someone in the class to already do the test.
Right. I'm not that
Been playing this game
actually,
for years.
I'm actually not that clever. I've got to say, I'm not that clever. So yeah, let's look at Occam's razor. You know, generally the simplest explanation is probably the right one. And the simplest explanation is that Abram's already taken the test. So Karina, can you believe Abram? One of your classmates? Yeah, there you go. So the question's got to be, why do people fail it? Why do people fail this test? I don't understand. I don't understand. There's no reason. No reason anybody should fail. Absolutely none. You've got a blueprint. You know exactly what you need to do, and you just have to do it. It's really that simple. None of their material is particularly hard, I don't think. Okay, any other questions at this point? Anything else? Anything about the structure of the test? Anything? I'm an open book here, completely transparent. If I was to be any more transparent, I'd be a pane of glass sitting in front of this screen. Ask me anything. I'll do my best to answer it. All right. Well, in that case, what I'll do is I'll start some review then, using this as the using the sample test here. And we'll start out with the first question here. When you diagram an atom of oxygen, you have blah blah electrons in the first row, and etc. Let's grab this over here. Okay, so the answers here are all numbers. So what you do is you find oxygen on the periodic table, which you're going to have in front of you, and you'll see that there are, let's have a look at this. So oxygen, I lost my, here he is. So oxygen has the nucleus. It's going to have 2 electrons in the first row, and we know that because there's 2 elements in the first row, hydrogen and helium. And then we see where oxygen is, it's 6 elements along the second row. So that's where the electrons are going to go, 6 electrons. 2, 6, and then there's 0 electrons in the third row. So that'll be your answers there. So you just put in 2, 6, and 0. That's it. Any questions? An atom of potassium has 1 valence electron. It's even telling you how many valence electrons it has. In this case, the charge would be +1. So if there are 1, 2, or 3, it will lose electrons to form something positive. If it's 5, 6, or 7, it will gain electrons to form something negative. And the number of electrons it gains will depend upon how many are needed to get to 8. So if it was in group 6, like oxygen, then it would be -2, because it would need two electrons to get to 8. Any questions so far? See, number 3 and number 4 can be about any of those things, topics I talked about earlier, valence electrons, energy levels, periods, etc. So in this one, we've got the number of valence electrons for Se. So we find out the group number for Se. And the group number is going to go 1, 2, 3, 4, 5, 6. So Se is in the oxygen group. So the answer would be 6. Then it's the period number for Br. The periods are the rows. 1, 2, 3, 4. So bromine is in row 4. So if its period is 4. Anybody got any questions so far? Okay, following electronegativities, what kind of bonding would be expected? I prefer the method we talked about in class, where we look at where the elements are in relation to each other on the periodic table. But if you've got Na and Br, they're really far apart. So I would go with ionic on that basis because one is going to take electrons from the other. If we had two elements close together over here in the non-metal section, I would say polar covalent. Then if it was the same element over here, I'd say non-polar covalent. In this case, though, it's ionic. Does anybody have any questions? This one here, highest ionization energy to lowest ionization energy. Well, what have we got? Let's go look at them. Ga, Ti, and Br. So we've got Ga, Ti, and Br. These are all in the same row. Ionization energy goes, the highest ionization energy will be Br, and the lowest one will be Ti. So make sure you get the order right here. So the highest ionization energy would be the Br, so that'll be 1. Ti will be the least, that'll be 3, which makes Ga 2. Does anybody have any questions? Okay. Module 3. So these are conversions. And the idea would be we're figuring out how many meters there are in this one. So we go back to the conversion table, which is here. We're going from meters to centimeters. So we can see it's 1 meter is 100 centimeters. We know that meters go on top. And then we have to make sure we get the right number of significant figures as well. But this would be 1.239 meters. Any questions so far? $7.7 ounces is how many kilograms? So we need to figure out how to get from ounces to kilograms. And the ounces here, we've got 16 ounces is a pound, and then we've got 1 kilogram is this many pounds. So I'll put this in first. So we know it goes pounds on top, 1 pound. We know it's 16 ounces underneath that to cancel the ounces. And then we need kilograms at the end. So we know 1 kilogram goes on top. And we also know the pounds are going to go on the bottom. But the catch here is I have to use whatever exactly is written here. And that is all the way through 2.204622622. And then I would do the math on that and come up with the number of significant figures correct as well. So I'll just grab the calculator here to do that. So it's going to be 7.7. That's going to be divided by 16. And then it's going to be divided by 2.204622. Okay, so that would be 0.22 would be the answer there to have the correct number of significant figures, so 0.22 kilograms. Does anybody have any questions? Next, we need to do this temperature conversion. We do have a temperature conversion formula up here that allows you to do this. This one is looking for Kelvin into Fahrenheit. So what you'd have to do first is take the kelvins, convert them into Celsius, and then convert that into Fahrenheit. So the 273.15 minus 245. And that's going to be 28.15. Sorry, I put that the wrong way around. Let's try that again. Because we want to get from Kelvin into degrees Celsius. So we'll subtract the 273.15 from that. And that should give, I think, gives negative 28. Let me do the calculator. It's too early for me to be doing math in my head. So it's negative 28.15. And that's degrees Celsius. And then that needs to be converted into Fahrenheit. And I do have a direct conversion for that. So F is equal to 1.8 C times plus 32. So it'll be 1.8 times that plus 32. So let's have a look at that. And then we're going to add 32. And we get negative 18.67 for the Fahrenheit. But we have to look at the significant figures here. And to do that, we look at what we started with. We started with something with 0 decimal places. So we need something that ends with 0 decimal places since this is all addition. So it'd be negative 19 should be the answer. So negative 19 degrees Fahrenheit. Does anybody have any questions? Okay. So for this one, we've got 15.3 mils in a graduated cylinder. The new volume reads 37.8. What is it? We know it's 35 grams. Okay, so what we need to do is do a subtraction first to figure out the volume of the stopper. So the volume of the stopper, which is going to be 37.8 mils minus 15.3 mils, which would be 22.5 mils. And then you can see it's going to be mass divided by volume. So it'll be 35 grams divided by 22.5 mils. And whatever we come out with is going to end up having two significant figures. Now, this is correct because that's one place past the decimal, one place past the decimal, one place past the decimal. So then our answer here, 35, divided by 22.5, which would be 1.5, 1.6 actually, 1.6 grams per mil. And we would plug these numbers in accordingly. This will be 1, this will be 2. The 22.5 will be 3. 35, that'll be 4. 5 will be the 22.5 again. And 6 will be the answer. Does anybody have any questions about number 10? Okay. So this will be the last one we'll do today. This one is about a prism. So you've got length times width times height. This is the volume, the volume of the prism, which is 5.0 centimeters times 4.0 centimeters times 2.0 centimeters. 5 times 4 is 20 times 2 is 40. So 40 dot cubic centimeters would be what we'd have for the volume of the prism here. Just taking that out to the maximum number of significant figures I can, which is 2 in this case. And then we take the density, which will be the mass divided by the volume. So it'd be 80.00 grams divided by 40 dot cubic centimeters. Which would be 2.0 grams per cubic centimeter as my final answer. 2 significant figures because these all have 2 significant figures up here. This one has 4. So this will be 1, 2, 3, 4 will be the volume, 5, and then 6 again will be the volume, 5 is the mass, and then 2.0 grams, that's the answer, that's number 7. Grams per cubic centimeter. Does anybody have any questions? All right, well, that's it for today. We will look at modules 5 and 6 on the test and how they appear and go through that on Wednesday. And in the meantime, if anybody wants to take the test, they're more than welcome to do so. Get your homework done early and there won't be, you'll have a lot fewer problems, I think. This is a good way to get started on the class. Start strong. It's something that's relatively easy. I think you should be okay with it. All right, well, have a good day, folks. I will see you on Wednesday. I'll see some of you later.
Thank you.
Thank you,
Professor.
See you later.
Hey, Professor.
Thank you.
Have a nice
See you
day.
later.
Professor.
All right, thank you all. Have a nice day.